Hey guys, how's it going? Welcome to another episode of Ferris Makes Emulators. This is yet another in this series of bug squashing, where we started looking at Space Squash to try and find out why it wouldn't boot, and have sort of come to the conclusion that it's probably not Space Squash that's actually the problem here. Pretty sure that it's something deeper that is like where actually the bugs in Mario Tennis are, symptoms of the actual bugs. Yeah. I don't really feel like explaining the whole journey again. I feel like I do that like every time I start the stream, these last streams. But some interesting stuff happened in the last stream, which was unfortunately 2 weeks ago because I had some work stuff last week. But basically, when just like printing out some registers and noting which ones were changing and a couple memory locations, noticed that it seemed that the graphics corruption we're seeing in Mario Tennis might actually be related to the sound player. Now, I don't think it's the sound hardware that's at fault yet, but it seems that at least the code that's clobbering the registers that we're looking at may be related to sound code. So I've been taking a lot of notes and just kind of trying to reverse engineer the code that's here. And yeah, that's been like one way to do it, and I want to continue doing that. However, I actually want to kind of indulge this idea that the sound code might be really related. Particularly, there's a place in the menu in Mario Tennis. So let me fix this font size really quick. Bam. But if we watch how these register changes, or the values of this memory location, it seems to be synced with when it's playing sound effects. And another thing we notice is that if I go from this screen into the other screen, you'll notice these change a lot, similar to when it's playing a sound effect, and it does play a sound effect. And I want you to notice something here. When I transition from this screen to the other screen, a sound will start playing, and the sound does not stop playing throughout the transition between screens. Does this like boo-doo-doo. But on the actual hardware, it just does boo-doo and then stops. And I've noticed on a couple other games as well, we seem to have that happen. Now, it's just kind of a hunch that this might be an easy way to find out where things might be going wrong. One of the things I want to do just to gain more overview of what's going on here, I want to actually print out where it does reads and writes to all the audio hardware registers to see if it ever tries to disable the sound, and also to like add watch points to those registers to find out where in the sort of the vicinity of the code that all that's being updated. If we end up finding like a place where it's like there's a specific routine to update the sound or a specific routine to play sound effects, maybe it has to do with a timer interrupt or something, then we might be onto something more interesting. But anyway, still, other than that, don't really have any more clues. So just going to keep digging and see what we find. By the way, hi to guys in the chat. Ashmedai, Tobez, Phil Daddy 69, Metal Voids, Daniel Collin, Dark Second, Skeleton. How's it going, guys? Ashmedai, more importantly, is your hair getting crazy long now? It's getting kind of long. I have kind of a ponytail thing going on now. Hey, Mad Moose. Hey, Zalkor. So yeah, before the stream, I did some more, just a little bit of testing on the actual hardware that I've got sitting over her. And yeah, basically just noticed that one distinct change when I go between the like game screen to the main screen. There's that sound effect that gets cut off on the hardware and doesn't in ours. And I'm just... that could be an entirely different bug, but it's a symptom of something that I've seen in a couple games. So I just really want to dig into that. Let me see if you guys can hear this. So it'll play some music, and then it'll go boop when I transition from the screen. Here it went broop and then just went silent. Whereas the one in the emulator makes like 3 tones. Hear that? That's so weird. So I'm just kind of being hopeful and hoping we can find a clue in there. So we'll start digging into that. Hey, local hoster. Hey, Michael C. Full crowd today. All right, so we want to go into the VSU in this case. And I think, honestly, okay, wow. Oh, right, yeah. So we're doing just everything is byte writes. Okay, that's fine. So then I can instrument this here. Apparently, it never reads any bytes from this audio hardware. That's fairly interesting. Actually gonna do a quick build with logging, or actually I don't want to do that because we'll get a lot of stuff here. But I do want to actually comment out this stuff that we have in the interconnect, I believe. Byte. Yeah, and I had this here. I'm just gonna get more of this stuff. I'm hoping we can actually find something this way. Oh, whoops. I forgot to close my window. Be right back. Okay, lots of register writes while it's playing the music. That we definitely expect. I always love watching this stuff. All right, so I quit at the end there because I want to see specifically what it's writing to, like at the very end. Now, as far as I remember, so it writes a bunch of zeros out here. I'm pretty sure this one, 580, is the control register here. Actually, I need to pull up a memory map of this again, which actually we have right here. Yeah. So these are going to be the registers relative to the start of this memory, so the exact values that we're seeing here. 580 is the sound disable reg, right? So it's going to write 0 to that, interestingly enough, but I think that's fine. I think if you write anything to there, no, this actually checks the last bit. I'm gonna look at the documentation and see if this is correct. Start by looking at the text scroll just to see if that lists anything. But I may pull up some other documentation for that as well. It might be that this sound bug is just another thing. Like if you're supposed to just read this as a strobe register and not care about this actual bit, that may be one thing. And if that doesn't fix our original problem, but it fixes a different problem, okay, well, that's at least helpful. So we'll see. Okay, so this is setting it to 1 will stop any sound channels currently generating sound. Dark Second says you should just try commenting it out. Yeah, I know that, but I want to see if the documentation specifically says that there's this bit. But we can try. We can try that. But it's gonna be weird if that fixes it and the documentation mention that bit. So we'll see. It could be that 0 is actually the wrong value to write here, and that might lead to some interesting stuff. Okay, we still got 3 tones there, so that didn't seem to be significant at least. Which is somewhat interesting. It avoids maybe it doesn't work because it hasn't got Nintendo seal of quality. Could very well be. The special magnetic properties of the seal are what make it work. I'm noticing here that it just sets enable to false. I think that should work to disable the sound like instantly. Yeah, here. If enable is true, then we'll do all this stuff. Otherwise, it's going to be 0. So that should work. Like diffs, don't know if it matters, but shouldn't that thing only check the last bit and then rather than the last byte? I believe it does check the last bit here. Yeah, this does check that one bit. It's just that when I printed out the register values, it just wrote the whole byte. Let me trigger this again, and I want to see what other registers are touched here. By the way, let me know, guys, if there's a bad echo or something. But I just don't feel like wearing headphones right now. But if it's a problem, I don't mind putting them on. Yeah, then it writes to a bunch of these addresses here. I just want to check what those are. Like 404. Which, yeah, so it's volume and then the play control for all these. So it basically sets them all to no volume anyway. So even if it wrote the wrong value here, this should still disable the sound from all the voices like we would expect. And this is not the worst way to do that, probably. It is still a bit weird that it writes 0. I might actually run a couple other games in here just to see if there's anything interesting there. But I wanted to, I thought I had at least another case or two where that sound thing was the same. It wasn't in golf, was it? can't remember which game it was that I was testing. Let me grab my little stack of games and see. All right. Because I thought there was another game where I had that same sound thing. And I don't know why I think it was golf, but I just feel like it was. Okay, actually, now I remember it was Tellero Boxer. I'm going to actually put that in instead. But I also remember having to wait a while there. Because basically I think it would only happen like as the demo mode it goes in this demo mode where it like shows a robot fighting, and when it wins there's like this crowd noise as like this confetti falls from the sky. And then that has the same sort of thing where that crowd sound ends up lasting longer than it should. I gotta wait a minute for that to happen. But while I'm doing that, like Jeff, and it doesn't skip writing the value to memory when it goes through the audio function you showed. I'm not really sure what you mean by that. Local hoster, off topic. I think I know the answer, but can we have a short 4 beats preview of the track you tweeted about? So he's talking about a track that I'm working on with Hoffman. Actually, I should say Hoffman's working on it with me because he's doing most of it so far. It's an executable music entry for Nova, which is demo party this weekend. So catch the stream. I'm pretty sure SceneSat will be streaming that. That'll be a fun combo. I don't know when the combo is, actually. I need to check that myself. I don't think I'll be playing a preview of that on the stream. But, like, you'll literally hear it on Saturday. Okay, here we go. Yeah, so that crowd goes, like, silent. Whereas I'm pretty sure in the emulator, it doesn't. And I wanna do the same thing where we're writing out the registers here. It's gonna take a second to test, but so be it. By the way, I'm getting seriously tempted. This is also kind of off topic. I'm getting seriously tempted to get back into some FPGA stuff this summer. And one of the things I'm thinking about is I have a couple of these Virtual Boys, and one of them has these like eye pieces where the like connections are kind of coming off. So they have these kind of line artifacts. Dark Second says I need save states. So here's the thing. I actually wouldn't trust a save state in this case because I don't know if it would, like, there would be some other state that might affect this that would end up in the save state, whereas this wouldn't, if that makes sense. So generally I do need save states, but to be fair, I don't think, like, I wouldn't feel comfortable using them in this case anyway while we're hunting for bugs. Skeleton, which language are you going to use? Still thinking about Verilog? Yeah, so it's either going to be Verilog or I did start my own language that is actually looks a lot like Haskell, but would describe sort of the whole state of the hardware. I'd have to do some streams if I really wanted to go into the details there. But yeah, anyway, what I'm thinking is that I might... here, the problem is I don't have a proper scope. Wait, hold up. Here we go. Okay, see these weird writes here at the end of this? So I stopped it as it was doing it because it just like it had the crowd and it went like this like glitchy stuff. And I wanted to see what it was writing here. And it looks like it has this like sample playback routine, which I did reverse engineer at one point. And then it must have just kept going. And I'm wondering, I think this was happening from one of the timer routines. I was hoping we might find something obvious here in the way that these registers are being written, but now that I'm just seeing that it's just doing these same writes over and over again, this may not be a shortcut to the information that I was after. Because I'm thinking that this was changing these values based on a timer, and then I'd have to reverse engineer more of that playback routine and the code that calls in the timer, or even some other code that might enable or disable the timer in this case. Not really sure if that might be relevant, but it could be. You know, I wonder, actually. This might be kind of a long shot here. Wait, why am I doing this with the hardware? Here's what I was gonna do. Or maybe it doesn't just work if I do that, but let's try. Actually thinking about disabling the timer. Just to see if it helps. I'm pretty sure I already did this back when I was debugging this the first time, but let's just see. Not blue spec for hardware languages. As I just know, it never reads from these values. Yeah, okay, so this still bugs. That's what we expected. It looked like syntax. But yeah, I'm gonna finish this thought on this hardware thing. I'm actually considering taking one of my extra virtual boy units where the eyepieces are like the connections are going bad anyway, and then trying to basically reverse engineer the protocol for the signals that's actually sending to the LEDs, the scanners, and then seeing if I can basically make a USB interface for this to have it actually output a video signal over USB or something. A lot of kind of unknowns, and it might be kind of a pipe dream. Wouldn't be a very quick project, but I'm genuinely considering it. Although as a more quicker and good enough solution, I could just buy a couple cheap webcams and just tape them to the unit or something. Should be kind of funny, but anyway, back to the bug. Yeah, okay, so I disabled this timer interrupt. That didn't help. Actually, speaking of which, just out of curiosity, did I call it exactly? Where's the fun in that? Be much more fun to do FPGA stuff. The problem is I don't really have the tools to reverse engineer the protocol. Okay, so with no timer in this game, it just nothing happens. All the sound was coming from that timer in Taylor Boxer, it looks like. Yeah, Dark Second. It should be related to the display interrupt, but I was just seeing if there was anything on the off chance that it was different. Be worth checking. Because you never know if some, like, it could be something weird going on, like the timer interrupt sets some variable result that then, or sets some variable value, and then something in the video interrupt will read that value. Like you never know how these things are connected. If software normally breaks in weird ways anyway, and when you have software running in a broken emulator, stuff breaks in even worse ways, or even weirder ways. I'm gonna let this run through like a demo mode. Warp mode is what I really need here. You know what? Honestly, how long would that take me to hack in here? Probably not long if I didn't really care about doing it nice. Yes, this even creates the window, so I should be able to do... Where am I doing the... So like, yeah, for example, it could be that that like we're not emulating part of the memory map correctly, and that could mean a value is different. It could be that the CPU is affecting some of the flags differently than we expect, which I'm gonna find pretty unlikely at this point because I've gone through many times the CPU code versus the datasheet and tried to match it to that as to the best of my ability. It still could be possible that that's what's going on here, which would make sense to me because we're still seeing some random crashes. We're still seeing like weird things like game objects will disappear in a couple games. This stuff like the graphics corruption, so it could totally be a CPU bug still. But yeah, my point is really that could have been. It can be so many things. So just trying a lot of things is just kind of the only way I know how to do this. Generally, I do suspect that if we keep reverse engineering some of the code that actually runs in this video hardware interrupt, then that's where it's going to be. But there's a lot of stuff in there, and it's kind of rigorous work. So I'm kind of just trying to see if there's any other additional clues that we can kind of, yeah, that'll give us kind of a better direction than just digging more into this mountain of code. But yeah, warp mode will help me test. So warp mode is where I'm basically just going to let the emulator run as fast as it can. And that may not be the easiest thing to do, just the way that I've written this. But let's just see. Basically what we want to do is we want it to not sleep. And we want it to not run in a loop like this. So I have running and debugging. I might actually make warp one of these 3 modes. That's probably a good idea. Do that. And I don't really care if the code's clean at this point. Whoops, wrong. statement there. Honestly, the easiest way to do this is something like, how am I changing this? There's probably going to be some crap here with doing the timing. Just run a bunch of cycles, do like 1,000 here or something. And just run that in a tight loop. Then, I mean, the nice part is what I'm doing here basically is just changing the top level bootstrapping stuff, which shouldn't affect the emulation at all. At least I feel like I've done a pretty good job at that. This I don't think will work as is. Oh yeah, first of all, I need a way to get into warp mode. We'll do this now. Actually, this will be easier. Yeah. I think we can just do this and then toggle it. Probably best. F11 is usually like full screen, but for this, it'll just be easier for me to reach there. No, I can't just skip the sleep here. Because and this is also why I don't think that this will just work. It's because I figure out how many, like the sleep is not what's doing the timing for us. That's just freeing up some CPU cycles. It's this code here that figures out how much time should have been emulated before it starts running. And then it says, okay, we need to have emulated this many cycles by now, and then it will catch up to that many. So I probably have to adjust the timing stuff for when it comes out of warp mode, which is what I'm a little bit worried about, but we'll see. But yeah, I need to skip the sleep and have it not actually measure time to figure out how many cycles it should run for warp. Okay, this did not appear to work. Oh yeah, because I did this wrong. I'll do this here, actually. Cool. Yeah, and this will have to catch up because of the timing. I'm going to wait for it to do that. Yeah, okay, there it goes. Yeah, so I need to also adjust Like, so when it starts and ends the debugger, it does some stuff with the timing. And where does it do that? Not sure where that code is, actually. Okay, here's what it does. It just resets the start time based on how much it's emulated. This should actually work fine. We can just do that here. Yeah, that should be enough to hack this. Maybe I want to increase one of those values. Yeah, this appears to work. Everything still works, which is nice. We're gonna have problems with like wrapping around the audio buffer, but that doesn't matter. However, I have a feeling we can run many more cycles here. And that might actually be a limiting factor for the speed. I love this. This sounds great. Yeah, I don't know why they do that. You know what I need, though? Instead of a warp mode, I need a ludicrous mode. High five to those who got that reference. Just want to see if I can get this faster. Okay, that's about as fast as we're going to get this. Hey, Okama. Hey, baggers. Yeah, they're really getting after it. Yeah, I'm just having fun watching this. How nice would it have been if we had this while trying to find that golf bug? Okay. Oh, I hate it when the console does this. Sometimes the terminal emulator in Nemesis does that. Gets all glitchy for whatever reason. Those drums. This is surprisingly stable, though. But I guess that's good. Again, speaks to a clear distinction of real time and emulated time. That is extremely important when doing emulators, I think. Definitely something we did right here. Now, if only I had this for the hardware. Yeah, it never disables the sound there. That's really weird. Just because I think this will be funny. Yeah, up the voltage for sure. Yeah, I'll just dunk the whole thing in liquid nitrogen. And then put it on my face. Because I'm just that cool. And there it crashed. Look how quickly that crashed this time. Okay, I want to do one more of these just because I think this is fun. Actually, two more because there's one I want to watch. I want to hear this Waterworld soundtrack. Okay, it wasn't as fun as I thought. But I want to watch the Mario demo, or the Wario World demo, in warp mode. Yeah, I should totally do that, actually. I should disable the console output for that. Hey, Alan Codes. Yeah, it came in at a good time, I think. Or at least came in at me having a good time. I didn't seem to go too much faster. Which doesn't really surprise me. I have a new lack of haircut. It's getting long enough that I can put it up now, which is nice because then I don't have to wear a hat in the summer. Yeah, it's just faster Wario World. Thanks, Ion Codes. So I think warp mode works. Now this feels super slow. Power of contrast. Whoops. Okay, I actually wanted to check the register output here now. And they are just stoked to play tennis. Yeah, I hadn't thought of that. I hadn't thought about that, Ion Codes. I guess I have. It hasn't felt like it in the last few weeks, though. Made a lot of progress, that is. But gotta figure out what's making these glitches happen. Oh, I missed it. Isn't that just gorgeous sounding? Just ride to the net and just twerks. There it is. Got it. Okay, yeah, so same thing here when it transitions away from that screen. Oh, you know what? I did forget to check if the graphics were corrupted after that. I'm going to run it again. But we did see that it writes the same, still 0 to the mute all register. And then, yeah, 0 to the volume and control registers of all the voices. So I'm just going to run this one more time to see if the graphics are corrupted when it comes back from that screen, because I can't remember if that was generally the case or not. But other than it writing 0 there, didn't see anything super strange. Like I was hoping. Graphics are fine. Then they're broken. So it's not, they seem to be mutually exclusive where it's like, it doesn't really matter if it writes all zeros to these like we expect. The graphics could either be corrupted or not. It also looked like the Tolero Boxer thing is probably different. Might be a symptom of the same bug, but yeah, it didn't look like it was going to be a shortcut that would actually help us find the real issue here. Bit unfortunate, but that's how it goes. So might just have to bite the bullet and keep digging into some of this code here. In any case, though, hacked warp mode, so that should be helpful for testing. Yeah. Okay, so it looks like, according to my notes, there's a value here, which I was watching. Let me disable this. No. Get rid of this for now. I'm just like leaving a lot of this print stuff in here because I can just go through that when I want to. When we eventually find the problem and I want to commit, then I can just fix that stuff then. It's here. I was watching a couple addresses. And yeah. Yeah, I didn't actually lose any. It's just back there. Daniel Collins, so I assume the game will update the tile data in memory at some point. We think the code will run correct, or otherwise there would be some corruption after the update. It would be possible to watch the memory after the update has been done, if that makes sense. So when I reverse engineered the data compression for the tile load stuff, the data compression code, I'm pretty sure it's correct, and I'm pretty sure it's running correctly. The compression code itself. And the reason I think that is because when I reverse engineered it, I got code that made sense. So I think that the code is correct. And then on the cases where it works, it's running without that. Like if I disable that interrupt from happening while the decompression is going, then it works. So the data compression routine on its own appears to be correct and run correctly. It's the combination of some of the code that's running in the video interrupt that probably shouldn't have run or is running incorrectly that clobber some registers that the graphics routine uses. So it's definitely that combination of things. But I'm certain that the code inside the data compression routine itself is working correctly. I'm fairly certain of that. But yeah. But maybe if I'm not understanding, because maybe I guess we could like I basically can detect when the corruption happens because it happens when one of a certain set of registers. So I hacked that a couple weeks ago, if you remember correctly, or if I remember correctly, rather, where it'll watch these certain registers that get clobbered that end up ruining the decompression routine. So I added a watch thing for that, so I can basically detect when that's going to happen. The interrupt. Let me see. So disabling the interrupt so it doesn't run in the cases where this sets it up to run. Like I'm pretty sure the interrupt is supposed to be running here because if we make the interrupt not run with the conditions that this expects it to run with, if that makes sense, then other games break. In particular, Space Squash doesn't start. And from a couple hardware tests I did a few weeks ago and some other research into some of the documentation again, I'm pretty certain that the fact that the interrupt is firing is correct. I think it's some logic within the interrupt handler that is not going going correctly. So I can detect when it's a little bit of manual work, but I can detect when the corruption happens. I can detect like what am I trying to say? Like I can detect when the registers are clobbered, and I can basically detect where that is. So I have that in some of my notes here. If I search clobber, here, we either get it here or here, and these both appear to be part of the same routine. So if this code runs, then we basically already had the issue. So something that was causing this to run is the problem here. And I think that's why I started watching the memory here. But I'm wondering if I can kind of get a more broad overview. Like I'm wondering if, what am I trying to say? Or need to think through here, because like, so I can detect when the clobber happens. And in fact, I can probably write code to do that automatically, because it's a set, like there's specific things that happen. Yeah, that's kind of what I'm wondering. I'm wondering if I can just like take snapshots of the state, particularly the memory. Yeah, that's kind of what I'm thinking, Daniel Collin, is I wonder if there's yeah, I think you're onto something there. If there's like, let me think through this a bit. So I know I can detect when the clobber happens, and I can also detect if there's a case where it didn't happen. And I wonder if I just like save out the entire state. I could just do that. In fact, a really easy way to do that is just derive debug on all of the things in the emulator, which should work for the most part. This virtual boy struct here. And then I can probably just dump that to a file. Because I would need to dump a bunch of successful. So here's what I'm thinking. I'm thinking that if we could, so for example, if I can save out the state, like there's different kinds of granularity which I can do this. If I can save out the state when we enter and exit the decompression routine, always, and then whether or not that pair of states encountered a corruption. I think that's probably the granularity that we want. Doing that with the interrupt could also work. So if those, because then if I can diff those, especially if I can see the memory and diff the memory, even if I can just go back and forth in Sublime and just like look at snapshots of that entire memory, maybe we can find some kind of pattern. Because the hard part there is we're going to end up with a lot of data that's not relevant. Like, for example, I know the video RAM's not going to be relevant. In fact, I'm pretty sure it's just going to be memory values and register values that are going to be what we care about there. So I could probably just dump those, but also I would like to dump some like register states would probably be useful. Yeah, starting with just the register is probably a good idea. Although I actually think the first time I debugged this, that's basically what I was doing. And I think all we found is that, okay, yeah, certain registers got overwritten. So I don't know if the registers are going to give us any valuable information, but I could try doing that just to start off with. So first what I want to do, I want to see if I can automate this, which I should be able to do. So before I was doing it by hand, so I set a breakpoint in the beginning and end of the decompression routine. And then when I hit the breakpoint in the decompression routine, then I would set a breakpoint for the frame interrupt, and then also a breakpoint at the end of the frame interrupt. And when I got the frame interrupt while we're inside the decompression routine, then I would enable a watch on certain registers. So if any of these registers are written while we're in the interrupt routine, that has interrupted the graphics decompression routine. That's kind of the case here. Yeah, it's definitely that the interrupt doesn't restore these registers correctly, for sure. It's just that a lot of the interrupt code doesn't touch these registers. And so what I think it is that there's some branch in the interrupt code that we're taking that we shouldn't take. And I'm hoping that by dumping the state that we can sort of see what's causing it to do that. And that's kind of what led me to these notes here, finding these particular values, because if we look in the code here, I can find where the clobbers are and basically the branches that would have been taken or not taken there. But it would be nice to sort of collect more bits of this data and not have to do it as manually. But I think what I'll start doing now is try to automate that. So I think for now, I'll just write something that'll print when graphics corruption happened, and then we'll run through the game a bunch to see if make sure that's correct. Because again, that should just be if we get a frame interrupt while doing the decompression and a certain set of registers were modified while we did that, then we have a corruption. I think that's the easiest way to do that. If I can do that, then that's automated, and then I can start working on dumping states during the different parts of that happening. I think that's a decent strategy to move forward here. Because again, like I could sit here and reverse engineer a lot of the code, but it's very exhausting to do that. So I'm kind of trying to see if we can sort of get a higher level overview of what's going on there. So I think that's a good way to do it. So where do I do this? Yeah, I could also do that. I think I'm going to end up doing that anyway. So first I want to make sure that it can detect when the corruptions happen, because then I can mark, like I can basically get pairs of save states. So like here's the state when it entered the interrupt and here's the state when it exited the interrupt. And if I can mark those pairs with whether or not a corruption happened during that routine, I think that'll be sort of the best info, and I should be able to automate all of that. Would give me some better things to dig through, I think. Bit abstract, but I think it should be totally possible to do this. So the nice thing is, with the way that we've hooked this up, every step, I should be able to check what the PC is here. So that should be nice. And I should be able to do it at this level, which is the appropriate level of abstraction, I think, at this point. Okay. So in my notes, I have these. So here's the decompression start. In fact, I'm even going to do this. I'm gonna comment these out for now. So this should tell me, it should print out a bunch of stuff when the decompression routine starts. Because the advantage of doing this is that we should be able to, like through diffing, we should be able to see, okay, these are the locations that are changing, which should hopefully narrow down our scope. Because that's really the challenge here. Is how do we find out what's not important? And that's the struggle. Because there's so many things that could be relevant. Let's try this. All these should be matched, which they are so far. And it also makes sense that this would have happened at the beginning because it would have been unpacking all these graphics. Cool. So this looks good. Yeah, I could detect all memory IO. I'm hoping that if I detect all the memory IO, you know what I wonder if I could do even is I think so. I want to just do state dumps first, but then I wonder if I can do like some state dumps that would give me, like if I can dump a bunch of HTML and then be able to like step through this or something. That might be really interesting. Sort of hack the UI together that way. And then if I do, well, I guess I can do that with diffing as well, but yeah, we'll see. I could also do it with colored terminal output, which would probably be easier. Honestly, another thing that might be useful here is I think we have 64K of RAM. Yeah, exactly, Duncan. Or just dumps to the graphics, or like make a second like debug window where I just always show the memory or something. Which would be kind of cool to have anyway. But yeah. Yeah, so we'll get decompression start and end, and then we'll get the interrupt handler. So what I want to do here, make a new state here, which is going to be his decompressing. Yeah, luckily MiniFB does support multiple windows. That may be very useful. Because sometimes, here's the other thing that I've noticed from doing this stuff and just general, like printf debugging in general, even though it's like it's the kind of debugging you do when you don't have better debugging, but at the same time, it's kind of nice to do anyway to see how stuff changes over time. I think there's something fundamental about the brain being able to recognize patterns, and I think sometimes printf debugging brings that out. So here we're gonna do this. So we're going to do, like this. And I think, right, so here we know when an interrupt will happen. So we can say if the exception code is 40, yeah, I think that's a really good idea, Daniel Cullen. Just show as much data as possible, just to let people see it. Important. Absolutely. Do this. Now, really what I would want to do is actually check the PC here, so that I can detect when it starts and ends, because this will only tell me when it started, but that's fine for now. Take this a step at a time. It's kind of a cool way to do this, I think. Although we're not getting... I have a feeling that the exception code is not just the last byte, which I should refactor it to do that. But it may not be right now, which is okay. If I just search 40, we'll be able to find the interrupt code, I'm sure. Unless that's in the interconnect. Here it is. Okay, so it's FE40. So we'll put that in there. Then it should be able to detect that. Yeah, after going down so many avenues so far, I think this is a pretty good idea. Probably should have started with this, but did not know this bug would be this elusive. Cool. So now we got some interrupts while the decompression happened, and all these are between start and end ones, so this looks correct. That's great. So I'm actually going to do this again here. I'll copy the address in a second. And then if nothing else, what this will give us is a map of just stuff that changed. And then we can at least know where to put the watch points to look for more patterns. And now each of these starts should have end of interrupts here, which is good. And yeah, so finally, we're going to do another state here. Is in interrupt and decompressing. Rather have a really long variable name than one with a not very clear short name. And then finally, we want to detect if we're going to clobber. Now, I'm fairly certain I think this bool here is just whether or not a watch point triggered. Right now, I think I just made that go with the other watch point. So I might have to hack something in here for this, but that's going to be totally fine. Definitely don't mind doing that. In fact, now after hacking so much in the emulator to like sort of instrument this, I'm actually quite happy with that approach. So we can kind of just build the exact debugging facilities we would need instead of trying to find like general patterns that would cover those same cases. Which I think would just be a waste of time. Better to just do this once, and then if we run into a similar case later, then we know that, okay, that's some pattern we should support probably. I think actually I did this when changing the registers. Yeah, because I had this reg watch thing here. Okay, yeah, so in this case, it just triggers the watch points. So let's do... You know, if I don't set any other watch points for this, which is going to be fine if I'm just dumping states, I can just use the watch point thing, and that'll be fine. So in that case, we just have this. If ret... actually, it's here. If ret.1... So if, yeah, self dot is in the interrupt and decompressing and ret.1, then we're going to print out clobber. The simulator's been really good for me in terms of learning how to do a lot of this stuff. Okay, this should have detected clobber, and I'm guessing actually it's because that state wasn't enabled. Yeah, because we have this reg watch. And actually, I don't want it to break back into watch points here. So let me do, this will be kind of ugly, but it'll be fine. So when we enter the interrupt, we can just do this. So we'll actually do this. Actually, even though this is redundant, I'm going to check all this. Actually, we don't need to check the reg watch. We'll do that. Then we'll do ret.1 is false. That's the ugly part. Okay, didn't like that. Reg watch enabled. This should do what I want. Because of this, it means that the actual watches don't work, which I think is going to be fine, because that's not what we're looking for right now. Bam! Oh yeah, we got, it's printing out all the times those registers were hit. So let's not do that. We'll disable the watch here if this happens. And then, yeah, so this is actually pretty good, I think. And actually, this is that specific register watch thing, so this is not the worst hack compared to our other hacks. Bam. So this is exactly what we wanted to see. Baggers, where's your pattern matching now? Algebraic data types can't save you. Yeah, so we got 4 times this was clobbered. Fairly interesting. So that's at least 4 interrupts that this hit here. And these are the different values it wrote even. Kind of neat. So anyway, what this gives us is we now have the exact conditions, so we know when interrupts started, we know when interrupts stopped, we know when clobbers happened. So we can do... add this as a bool as well. And we can do this, and then we'll do this. Yeah. So now here, we can, if we save the state here, in fact, I'll even comment these guys out. If we save the state here, we'll get the state as it entered that. If we save the state here, we'll get the state as it leaves. So this is entering and leaving the interrupt while the decompression is happening. And then finally, because of this, we'll know that when we're dumping the state, whether or not we had a clobber. So we can do pairs of states here, I think, which will be nice. And the other cool thing here, all we have here is the CPU and the interconnect. I'll start with just the registers for the save state here. I think that'll be easiest. But if just want to run this one more time to watch the output here. At the rate this is going, we're going to end up debugging this at Solskogen. Assuming that the demo is done by then. Yeah, so there we got a clobber. Here we got a bunch of clobbers. There's some more. There's some more. Cool. This is totally working. So we've automated the clobber detection, which is rad. I kind of want to erase these prints here. Yeah, Rust did just save me from an uninitialized variable error. I actually, multiple times during this stream already, I've thought, man, I really like Rust. And that was one of those moments. But I feel like I talk a lot about how much I like Rust, so I didn't say anything. Okay. Honestly, I'm just going to start with the registers, I think. So how do I print the registers normally in the debugger? I probably just print them out. Yeah, I do. Just do this. Cool, I'll copy that. It was in here. In fact, I can start just by printing these. Do this. Yeah, I can do derive clone on like the CPU as well, because I don't have the registers in the separate struct from the CPU. And I guess, yeah, we have some other states here that I don't really want. I'm thinking I'll just dump this to text files and do the diffing there. Or maybe we'll produce some output. I'm not really sure how I want to do that yet. But for now, I'll start by just printing it. Cool. And I think, yeah, we actually probably won't get much interesting stuff from the registers. But printing out, especially the work memory, that's the thing that I want most here. Let's actually... I would actually like to stuff this in a data structure. Maybe I'll just make a save state thing that'll contain the bits of the CPU I want, and then I can just copy those out. And then, like, the memory. In fact, I think I have a work RAM struct here already, and I can just clone that. Yeah, I'll probably do that. I'll probably pull the registers out into a data structure there. I'll just put it down here. So we have PC. We have the GPRs, which is going to be 32 of those, I think. PSW, which we can just treat as everything is U32s. And then not sure how I want to print this stuff yet, but we'll not worry too much about that. We'll just do this. Actually, we can do this. And then the other ones can just sort of be like this. Oops, PSW. That should compile, at least. And reg ECR is apparently U16, which is fine. And I need to make this mutable. And then we get a bunch of warnings, but it compiles. Fine. So then we can do... something like that, I'm thinking. Then we can do... something like this. And we can do self.interconnect.workram.clone. And as long as we derive clone here, that should work. Yeah, maybe one of the nice serialization things will work. If I'm just gonna write text though, I'll probably just do derive debug. It'll be fine. Okay, so we haven't imported that. That's fine. Interconnect is private. Oh, workaround is private. Yeah, that's fine because we can just make that not private. So now we want to do these sort of pairs of states. And how do I want to do this? Dear Colin says, have a pointer in the WRAM struct. I assume the pointer will be the same. Yeah, good point. That might cause some issues. Yeah, that's going to end up pointing... If we just clone this, that's going to end up pointing to the first bit of memory. Now, I think that's actually fine as long as we are careful to actually read the bytes value here. You know what I might do, honestly? No, I don't want to change that because that'd be annoying. Let's just make this public. And then, yeah, I'll just print this out by hand and just make sure to read the bytes and not via the pointer. That'll be good enough. But yeah, you're right. This pointer will definitely have pointed to the other bit of memory. That's a speed optimization that this is doing, which works until you do stuff like this. But it should copy the data at least. Oh yeah, I should actually do that. Just copy out the bytes. That's a good idea. So this is a box of VIIIs. That's even better because then we can kind of just ignore that. Do that. Yep, that still works. I have a feeling that this will be enough information for us to actually find the bug. Maybe it won't be obvious, of course, where the bug is, but I have a feeling that workram is where it's going to be. So how do I want to dump these? Do I want them in separate files, maybe? I think if I dump these out in text files that have like names like 0101 whatever, and then append -clobber at the end of the ones that had the clobber, I think that might be good. Because then I can look at those side by side in whatever I want to look at those with. Maybe that's the easiest. Although, maybe I can just collect all the structures. Because from doing some of the packer work I've been doing recently, I do actually have some stuff that can dump like heat maps. And I wonder if the easiest thing to do is just hack together stuff that'll dump out like full 64K mem dumps here. And then color the bytes that changed. Because then I can kind of get a diff between two states rather than displaying the two states and then diffing those in like an editor. Unless, I wonder if Sublime has like nice colored diffing tools. Because then that'd be the easiest. Let's see if we can find some nice text diffing that'll be good. Because what I don't want is a diff that looks like Git. Like that gives you this kind of diff. I don't want that. I would like to have like, maybe it'd be hard to find, but I have like if I print these states, it's the same amount of information, so it's going to be like identical formatting on both, so it'd be really nice to just visually pick out the stuff that changed. I'll probably also print out along with the memory some stuff like to see the row and column, although it'll be a lot because it'll be 256 by 256. Shouldn't be too bad. Yeah, meld looks like it's going to give me the kind of diffing I don't want. Because, yeah, particularly I want something that can hopefully like overlay the differences. Because I'm going to end up with a bunch of two-dimensional data, basically. And that's kind of what I'm trying to optimize here. Side by side wouldn't be too bad. Which I guess is what these tools are going to give me as well. But it needs to show me like it's going to be hard to pick out the values if it's going to highlight the whole line. That's kind of what I'm worried about here. And if I have to do it myself, I'll just do that. But this really seems like something I should be able to find a tool for. It may be that I end up just using a binary tool for this, honestly. Which would be fine because, like, especially for the memory, that's the kind of dump I'm going to have anyway. In fact, if I just dump the 64K memory, that might be the best way to do that. And I could probably just tack the register values onto the end because then it'll show me the offsets as well. I think that's what I'm going to do, actually, is if I dump binary, the WRM first and then just the regs at the end, I think that'll work really well. And then I can use a binary diff tool, which should give me what I want. Yeah, I think that's what I'm going to do. The only thing then is I just want to name the files according to, like, I want these to be grouped. I want like the start state and end state to be grouped, so I don't want to name those. vbin diff. Yeah, that looks really nice. That looks more or less exactly like what I want. Yeah, so then I just need to start writing out these states. So we'll do... Yeah, sometimes those older tools are just exactly what I need. Like, I still use Ollie Debugger because it's just so good. And I just know the interface. Yeah, we'll do... do a dump index. Yeah, then we can just use the has clobber happen thing in there, and that'll be fine. And because this is on self, it'll also have the dump index. So this is actually really nice. Yeah, this will work. And then we don't really need the state object, which is fine. Let's do that. And then we dump. So we'll do this. And we'll do, I think we need, actually this should work if we just do format. We'll do unwrap here. And then here we'll do the name. We do want to know if it's begin or end. I don't like using Boolean states here, but whatever. This is fine. I'll do this. Ugly as hell, but this will be fine. And then do this. All right. Do that, and then we should be able to do, we're going to write all of the work RAM. We should be able to do that because it's a bunch of U8s. And that'll give us the RAM. And from there, I could just dump this. I'm actually going to skip doing the registers for now, because I think I really don't think they're going to be significant, actually, and I think we might have like lost the information that was in them by the time we leave the interrupt handler. Maybe I'm wrong about that. Anyway, I'll start with this. And then we're going to need a couple traits. And we need states workram. And then we don't need this to return anything anymore. Oh yeah, good call. Need to update the dump index for sure. So yes, we'll do Hukim Devo. Ferris, you have a strong background in math. How necessary has that been for utilizing functional languages like Haskell? I don't think I have a strong background in math, to be honest. Or at least not terribly strong. Like I guess I've done a lot of stuff with lighting, but I still don't consider my math to be very strong, to be honest. So I would say it's not that necessary. Just want to see that we're starting to get these. Oh yeah, here we go. Beauty. Although I should have done these, I'm actually gonna do this with double digits. But they're all 64K, which is exactly what we wanted. So this is looking good. Yep, should be good. But grain of salt there, I don't use Haskell very often. And when I do, I have to look up a lot of stuff. It's not a language that I would consider myself very comfortable with. There we go. Now we're getting good stuff. And there we got some clobber. Ah, one more thing. I'm actually updating the index wrong. Only want to do this on the end so that we get these grouped. That should do it. I'm going to share this VBin diff link. Yeah, so now you can see here, they're actually grouped by the number, which is rad. So let's give this VBin diff thing a shot here. Need to extract some stuff. That's literally just a bunch of demo archives. That's awesome. Yeah. Oh, I actually need to invoke it from the command line. No worries. Do that. And we'll do so I want to do 04 versus, actually we'll do it from here. So we should be able to do then 04 begin and 04 end clobber. And it couldn't initialize the windows. That's a bit annoying. Maybe that's why I thought I had to do it from the command line. Well, I might have to use a different tool then. It's possible it doesn't like MSys, but I think it's probably more likely that that it's just older. I mean, I could try doing it from command line. Come on. Oh yeah, compatibility mode might be a good option. That's a good point. I'll try that. We'll make it Windows XP just because. Then I got permission denied. That's what I'm gonna get. That's annoying. Let's see if I can do that with. Oh, that's so annoying. Okay, let's do. I'm just gonna try another tool. So I usually use HXD. I wonder if I can do a visual diff. Right, it doesn't do a diff though. Hey, John Hunter. Nope, the bugs have not been squashed. So I wonder if BSDiff is on Windows. Let's try that. Okay, the Windows link was broken on the official site for that. So that's good. There's WinDiff from 1992. Which... All right, let me try something else here. I have to look over my Virtual Boy. Yeah, so even with the compatibility stuff and running as admin, vbindiff didn't appear to work. The HXD is not going to work because it's not going to do visual diff. It's only going to find like the first difference and quit. So that's not going to help. Let me try I want to try the compatibility mode for a different version of Windows here just to try. And then, yeah, it's okay. So that's just not going to work. So screw that. Okay, well, don't need that then. Yeah, so BSDiff had a broken Windows link. I think I said that. So that's not going to work. So yeah, at this point, I'll probably just do my own. And that's going to be fine, I think. See if I just have these tools, like hexdump and diff. Right, so with this, yeah, this might work. However, this did not give me the whole dump, did it? Totally didn't. Oh, did it truncate bits that were 0 or something? That's not what we want. Because if we have a bunch of zeros in one of the diffs and then not in the other one, then we're going to miss that. So that sucks. Okay, so dash V should work. If we do this, okay, so we want dash C, dash V. There we go. Then we get the whole thing. Or dash CV, which is fancier. So with this, my shell foo is pretty weak, by the way. So if I can pipe this into a file, do I do this? Something like that. And then we should get that, but that is not what I wanted because it didn't do the new lines proper. Can I do that? Or is that an OR thing? Ugh. Actually, maybe it just didn't read it properly. That's probably the case. Yeah, okay, so this did actually work fine then. So that's good, and then we'll do like that. And then we should be able to do the diff. And this, what do we want here? So Mad Moose suggested capital U3. And I want to know what that does. Oh, here, unified. Let's see what this gives us. And then we should be able to do the files. Okay, now unfortunately, yes, this generates the actual diff. I don't have color diff. Doubt that'll work. Oh, actually did. All right. And then this is probably just going to colorize the diff that this gives us. Which, okay, so that gives us, again, a textual diff. So close. But I would love to see it where it showed us the actual bytes of the diff here. Is that possible with showing diff? Because that would be ideal. What this Y thing does. Okay, so that just gives us the two files, but did it highlight changes? Gonna be a lot of stuff here, but didn't seem to. All right, I'll try CMD as administrator running VBDiff. Ugh. Okay, this actually did work. V-min diff here. And I can go to the next differences here. Till it gets to the end. Then it looks like I'm screwed. So this appeared to work. It didn't give me the best interface, but at least we saw kind of where the blocks were. Try some of these other options as well. CMP-L. Just try this. Okay, so this gave me at least where the differences were. And I guess these are file offsets. Right, yeah, because this was the byte numbers and differing bytes. I mean, what I really want is to have these laid over each other and do it visually. So I honestly am probably just going to do HTML dump for this. HTML dump. Because especially if I want to compare specific differences as well. And what I'm thinking is that if I can do... I think I'm just going to do that, honestly. Because if I can do HTML dumps of these pairs, then I can sort of have those open in different tabs and then be able to go between those and then see... Yeah. See if I can see any patterns there. I think that's probably my best option at this point. Anyway, thanks for the help, guys. But as far as I know, that's what's going to be the sort of best thing here, rather than trying to save some time with a tool like this. So let me pull up some code elsewhere. Okay, so this is just some heat map stuff from one of the compressors I'm working on. And if I just copy a bunch of this, we'll be able to do what we need to do. Although, actually, I want to use a different one that has not as crap code. Then, yeah, then I can just use these different two of these different heat map colors to see where they're different. This will be fine. So in this case, then what I want to do is instead of writing out the file here, I want to take the state and then, yeah, we'll do it this way. This will be easy. kind of annoying to do this, but this will be fine. This will be fine. I can do... Or we can just move this, actually. We'll do that. Okay, so then we're going to have something like this. Get rid of these bin diffs here. So we should be able to, yeah, copy this. And I think I have this as output. And we'll copy some stuff here at the end. Change the title. Because that matters. And then write the... Oh yeah, that is actually correct. Nice. Or whoops, that is not the end I want. I wanted this end. Although this will probably be useful anyway. Yeah, because we'll do this. Yeah, because we'll do spans like this. Actually, it's going to be really similar to this. Although we'll just do a span per byte because why not? Yeah, Radar probably has it. I'll probably wreck my hand trying to get to it. No, I think Radar is really cool. Just one of those tools that I don't like. I always use it once or twice, not very often, and so it's always a painful experience. It's one of those tools that you have to live in to learn to like, I think. We'll do that. Don't know why I have a space there, but yeah. Do that, and then we'll do something like this. And we'll use heat map 0 and heat map 9. honestly, that may work, except I have a feeling this unwrap is going to want to take ownership. But we'll see. On codes, how did you get into writing emulators? Like, why have you decided to make them? So I've been a demo scener for a long time, doing demos, and one of the things I really like about the demo scene is that there's a pretty active, like there's sort of active subgroups in the demo scene that do a lot of stuff for old school platforms. And as someone who grew up with a Super Nintendo and someone who really loves the demo scene, I also like sort of fell in love with a lot of the C64 stuff that I saw and some of the Amiga stuff. And so through that, I kind of really had a curiosity about these machines and how they worked. And in doing so, of course, you cross paths with emulators. And of course, emulators to teenage me just seemed like magic. But as I got older and started to really like understanding how bits of hardware worked, they were kind of a really natural way to really learn about a piece of hardware is to write an emulator for it. Now, the problem is emulators are a lot of work, but I tend to really like learning about a lot of these older systems at a very deep level. So it's work that I find really rewarding. So I think it was mostly that sort of sparked my interest in emulators. Yeah, so the byte we didn't get. I'll write out the end byte. And you know what we can do? This is going to explode the size of the file, but it's going to be fine. Yeah, good call. I can do ASREF there. Perfect. Now it didn't like begin state. Begin dump, yeah. I wouldn't call this emulator that simple at this point, to be honest. Like, yeah, Dynarec is more complicated, but there's a lot more to an emulator than the CPU. Yeah. See how long it took to dump those? And they're like 4 megs each. Great. Perfect. I could totally do stuff to optimize that, but I just won't. So now if we want to look at one of these. Here we go. So yeah, so we have some of these that are brighter. It takes a while to load because I did a span per byte, which is bad. In fact, this is worse than I expected, so I think I'm going to optimize that, which I actually had code in the other one to do, so that shouldn't be too bad. I'm also going to bump up. Actually, 64 is a good row length. I should do the address for all these, though. I'm going to do that. In fact, I'll even do it like this, where we do a different color span. I'll just reuse the ones that are here. Like this is green. It looks like heat map 6, so I'll do that. Funny. Do that, and then we'll do. So I want the address here. should only need 4 decimals for this because it's 64K max. So that should work. So this will give us the address every row, and then yeah, we want to separate out these spans. So we'll do this. And I think, I think the easiest way to do this we'll do something like this. If we take the, like, let's say this was, we only need, here's what I want to do. Just hack it like this. A little bit ugly with how much state there is, but this should be fine. These are going to be heat map 0. And we want this one to be heat map. Heat 9 was actually a bit dark. We'll do heat map 8. So if they're different, we'll do heat map 8 here. That should be significantly smaller. I didn't like that. Oh yeah, we don't have begin by here, but that's fine because we shouldn't actually have the parameter there in the first place. Now it should be much less data. I would recommend writing an emulator for Game Boy. I think Game Boy has a really good balance in terms of not being ridiculous amount of work. But yeah. Yeah, so this is much faster to write, which is what we would expect, and it's much faster to render. So now we have the addresses on the left, and yeah, now we can scroll through this nicely. So here we see the different parts of what changed. And this is pretty cool. Especially because this is a bunch of areas that I don't think we were looking in before. So what I want to do, let's scroll down. Like 22C0 seems to be a place where these agree on, except here. Oh no, that's the same place. Kind of line these up here. So this is particularly interesting here. This one changed a lot of stuff, but these couple didn't, and we still got clobbers. That's pretty interesting. And if I hover over these, we can see what the original one was. So what it changed to. So what's interesting here is that for the most part, a lot of these are touching the same values. Yeah, that Ultimate Game Boy talk was really cool. The Ultimate C64 talk also by Michael Style is also awesome. So yes, a lot of these are touching the same values. However, I actually have a feeling that like this is, I think these like 5, 6, 7, 8, 9, those dumps that I have here are actually going to have a lot of like not much stuff changed, because I think the conditions for the clobbering have already been set up when these clobbers run, because all these happened as I was going back like in the same screen transition. And this 4 one is nice. I wonder if I can compare 3 and 4 here. Here we didn't have much change between the two, which is somewhat interesting. For example, like 2 and 3 here. Yeah, nothing changed there. And I wonder, because there's got to be other parts here that changed too. And there may be some interesting stuff there. Overall, though, there's not that much stuff that's changing here. And I think digging deeper into this is probably a pretty good place to start next week, seeing as it's 10:30 already. So I think I'll do that. So I think next week we'll continue down this path of trying to isolate what is actually changing and seeing if we can get a better look at that and have that kind of guide what we look into next. But I think this was a good strategy, is to try and sort of automate this process of finding these diffs, and then perhaps augmenting these as well would be a good idea. So yeah, I think I'll call that good for today, and we'll continue on this bug hunt next week. Speaking of Dynarex, I think one would actually be pretty fun for this emulator. However, I'm a little bit adverse to doing it, because one of the things I want to do once we get the compatibility set up is start working on the libretto stuff and making that really nice. And the portability there is going to be significantly worse if we start doing Dynarex. So as interesting as that would be, I'm definitely going to save that for a rainy day at least. But anyway, this was fun. At least we went on a couple tangents that probably weren't related, and then also, yeah, started working on doing this kind of diff. So I think this was cool. Anyway, thanks for hanging out, guys, and I will see you next time.